My name is Conrad Michelo Chisumpa. Welcome to my lecture series, mathematics lecture series. Today we're going to talk about basic algebra. We will go straight into addition and subtraction without wasting much of the time. And we're going to do a couple of examples. Algebra is the type of mathematics that uses letters to represent numbers. We will show how letters represent numbers in each and every thing that we're going to be doing tonight. Yeah. So here are some of the examples. Simplify the following algebraic expression. 4a plus 3b minus a plus 6. 3c plus 2d plus 6d plus 60 plus 6c, minus d. 8a plus b plus 7 plus 16. b plus f plus 16 plus 21f minus 4. 6x plus 8y minus 2xy minus 9y plus 16. Let's go to the solutions and see how each of these questions are done. For question A, 4a plus 2b, 4a plus 3b minus a plus 6. Here, we can see that these are what I am underlining here are what? Terms of an expression. This is an algebraic expression. The whole lot of this thing you are seeing here is an algebraic expression. And each and every individual letters and numbers attached to them are what we call terms. Numbers which are attached to letters. A number here which is attached to a letter, for example 4, is called a coefficient. A letter here which is attached to a number in an algebraic expression is called a variable. Okay, we will learn more about that as time goes on. So here we are going to get, for us to add or subtract this, to be able to add or subtract this, we're going to get all the numbers, all the terms which are got like letters, group them together. So here from this expression we see that we've got 4a and minus a. These ones which have got a's, we put them together and add or subtract them. When we add or subtract this, 4a minus a, we get 3a here. We can notice that 3b doesn't have any other term which has a b on it. There's no term elsewhere in this expression which has a b. So 3b, we bring it like this. And 6 does not have a letter on it. We'll bring it like this. The terms that don't have letters, we call them constants. So here 6 is a constant. We'll bring it like here. So here we've got 3a plus 3b minus 6. To avoid confusion, you can leave this as an answer like this. This can be an answer on its own. But for exam purposes, you will be required to simplify this further into its simplest form. What do? You remove 3. You factor out 3 because 3 is common in all these terms. So you remove 3. And here you have open bracket a plus b minus 2. Where does 2 come from? When you divide 3 into 6, you get a 2 because 3 goes into 6 2 times. Let's go to the next question. 2c plus 2d plus 6 minus d. Here we get the like terms, we put them together. 3c and 6c. We bring them here. 3c plus 6c. What do we have? We have a 9. We have a 9c plus 2d minus d. We bring the d's as well together. We have 2d minus d. We have 1d. You don't write 1d when you have a 1 and a letter. You don't write 1a or 1b or 1c. You just write a or b or c or x. It is known that you are talking about a 1 in algebra. You don't put 1 with letters. Yes. So those are some of the rules that you're supposed to know. On C, 8a plus b plus 7a plus 16. What do you get? Put a's together and b's together. So here, 8a and 7a, you add these together, you get 15a. And b, there's no term with a b here. You bring it like here, like that, b. Constant 16, you bring it here, 16. So you have 15a plus b plus 16. Okay, b plus f plus 16 plus 21, f minus 4. Collect all the like terms together and do what, friends? Eval and simplify. Okay, add or subtract in the same manner. So at the end of the day, you get 17b plus 22f plus minus 4. Okay, next chapter. 6x plus 8y minus 2xy minus 9y plus 16. Here you can simplify on your own and you are going to get this at the end of the day. Let's go to collecting like and unlike terms. We are also going to look at substitution. Collecting like and unlike terms is just a similar thing that we were doing there, except that here it's just a similar thing that we were doing on addition and subtraction, except that here we're going to focus on this, the idea of the concept of grouping the like terms, like the terms which have got same letters, you put them together and evaluate, and those which, and in that particular order, starting from letter A to letter Z in the index manner, So here you have got 3j plus 5k minus 6j plus 3 plus 2k, and these other questions that are followed. So let's go to solutions. Um, 3j plus 5k minus 6j plus 3k plus 2k. Okay. Here we're going to collecting like terms. You collect all the terms with common letters, put them together as usual. 3j and 6j. Then in the same way, you bring 5k and 2k. You put the k's together, and the j's, you put them together as well, and the constant 3 at the end. So you add and subtract these in the manner they are given, and at the end of the day you will get negative 3j plus 5k plus 3. That is our answer. 7x plus 3y minus x plus 4y. Procedure is just the same. At the end of the day, you will get 6x plus 7y. Okay. U plus 5v plus 7u plus 16 minus 8v. The procedure is the same. Collect terms with common letters and put them together. Then you add or subtract in the manner they are written in index order. Don't put v at the first, don't put z at the first, then you put a at the end and constant inside and everything. Put them in index order. Your work should be smart, your work should be perfect, clean. Don't confuse the teachers. Okay, yeah, don't confuse the teachers in exams. They'll just throw out your exam paper and mark everything for you as 0. 3p plus 6p plus 2p, 3p plus 6q plus 2p plus q. What do you get? 3p plus 2p. Put them together as well in the alphabetical manner. Then you are going to get 5p plus 7q. Okay, let's go. Given that a is equal to 4, b is equal to negative 3, c is equal to 2, find the value of the following expressions. Here, that's where we are talking about substitution. Substitution means replacing. In algebra, substitution means replacing numbers where there are letters. So 4ab squared c, 3bc cubed, 15ac a to the power 4c. Why do we have 4ab squared c? Where there is a, we put a 4. Where there is b, we put negative 3. And where there is c, we put what? 2. That's how we deal with this. And we multiply and add and do whatever we want, depending on what we are given. So these are just simple examples here. 4, then here we had a, then we have replaced a with a 4. We've replaced b with negative 3 and squared it as usual. And here we have a 2. So we have 4 by 4 by 9 by 2. What do we get? 288. And you are home and dry. 3 marks in the exams. 3bc cubed. Same order. Same thing. Same procedure. 3, and since here b, we have a b negative 3, and we put negative 3 here, and we have a c. Okay, c cubed. Okay. There's a mistake somewhere here. So here we're going to have is equal to 3 open bracket negative 3 close bracket, and we have 2 to the power 3. I'm not using a calculator. I am using my head to evaluate this. So here we have and 3 by negative 3, we have 27, and 2 to the power 3 means you multiply 2 by itself, like 3 times, which means 2 times 2 times 2 equals to 8. So here we have 27 times 8. What is 27 times 8? Use your head, no calculators. We have 8 by 7, we have 15. Okay, so 5 carry 1. 8 by 2, we have 16 plus 1, 17. Wait just a minute. 8 by 7, 8 multiplied by 7, that's 56. 6 carry 5, yes. 8 multiplied by 2, you have 16. 16 plus 5, 21. So the answer is 216, friends. Okay, forget about this. The answer is 216. So let's go to part C. 15 a to the power 4 c. 15 4, because a is 4. 4 to the power 4 multiplied by 4. Calculators not allowed in the exam as junior secondary grade 9 students. Next, multiplication and division of algebraic expressions. Simplify the following algebraic expressions. Okay, try to do these problems. Try to solve these problems by yourself and see what you get before. Okay, yeah, before you replay the video, just try to pause the video and solve these for yourself and see what you can get. Okay, I guess you've solved the problems, and we expect that you have found these as your answers. 8a b to the power 3 c. How? You multiply everything outside with everything that is in the brackets at the same time. You see, simple as that. So you have, it's just a straightforward thing. 4ab squared times 2bc. 4 times 8. 4 times, multiply the coefficients. 4 times 2, 8 outside. A, there's no a inside, you bring a like that. B squared, there's b inside. B squared times b, b to the power 3. And c, okay, you bring c outside like that. Then here, what do you do? What is happening here? How do we get this one? It involves cancelling. You cancel this, and here you remain with a y squared, and you cancel x to the power 3. Here you remain with x to the power 2. And how many times does 4 go into 16? It goes on like, it goes in like 4 times. 4, therefore you have 4x squared y squared again. So this should be your answer. Simple as drinking water, right? Yeah. 27ab to the power 5 over 3b squared. Again, same procedure like for part B. You are just cancelling the common things at the bottom with those at the top, with those on top. So b's will go at the bottom. B, you remove the b's, and here how many b's will you have? You have 3 b's on top. So, and a, there's no a at the bottom. You like, okay, how many times does 3 go into 27? Goes in 9 times. So you bring it everything like that, the way they are. expansion and factorization. Expansion involves expansion of algebraic expressions involve, if example you have a number 4 here, and okay, example, if you have a number 12 here, and you have factors of 12. What are factors of 12? 1, 2, 3, 4, 6, and 12 itself. So this 12 is a number where these numbers at the bottom are factors. So if these numbers are in their factor forms, you have 1. If you express 12 in its factor forms, let's say 1 and 12, they tell you to expand 1 and 12. You put 1 and 12 in two separate brackets, and they tell you to expand 1 and 12. They are simply telling you to expand, to multiply 1 by 12. Here, again, if you want to expand, the other way you can expand 12, these factors to get the number 12, you can also multiply 2 and 6. If you multiply 2 and 6, it gives you 12. If you multiply 3 and 4, it gives you 12 again. So in the same way, it applies to letters. It applies with letters. If you have letters like xy, then here you put x, meaning the factors will be x and y. You multiply x and y, you are supposed to get xy here, back to xy. The action of you multiplying smaller factors to get a bigger product is what you call expanding. Okay, so example, expand the following algebraic expressions: a plus b, a minus b, 4x open bracket, x plus 3y. 4a, okay, a plus b, a minus b. What do you get? A squared minus 4ab. Okay, a plus b, a minus b. What do you do here? These two are factors. Now they are, in short, they are asking you to get a bigger number where these are factors, which when you multiply these should give you a bigger number somewhere, a bigger expression there, a bigger expression, which is an expanded expression. Like when you break it down again, you should get back to this a plus b, a minus b, So how do you do that? You multiply everything in this bracket times everything in the brackets here. So how do you multiply? You start by multiplying a, you multiply a with everything that is in the brackets on the right hand side. Then you come back and multiply by b. We multiply b with everything that is in the bracket here. So how do you do it? A times a, you get a squared. Then you come back, a times b, you get minus, okay, a times minus b. You multiply everything, including the sign before the letter. You have minus ab. Then you come on b here, b times a. You have plus ab, there's no minus. Then b times minus b, negative b. You have minus b squared. Then what do you do when you get this? You add and subtract to get the final product. the final expanded form of this. So here you have a, how many terms I've got an a squared here? There's just one, a squared. You bring it down here. How many terms I've got an ab? Two. One is a negative and the other is a positive. So if one is a negative and the other is a positive, and they've got equal coefficients, and the coefficients are equal, which is 1 and 1, they cancel. So here this and that will cancel, and you have negative b squared. You bring it like that, and here this is the expanded form of a squared minus b squared. The same is true here. 4x open bracket plus 3y close bracket is equal to negative 4x squared plus 12xy. Yes, you multiply 4x with everything in the brackets here. That is expanding. You have expanded this expression. Let's go to factorization. Factorize completely the following algebraic expressions. Now here that factorizing, here you have a 12. In this 12, like I illustrated previously, they are in short asking you to break down 12 in its two possible factors, such that when you multiply those factors, they should give you a 12 again. What are the factors of 12? 1, 2, 3, 4, 6, and 12 itself. So what are the two numbers here? Choose two pairs of, I mean, three or two pairs of number. How many factors are here? They are like 6. Yes, you choose a pair of numbers such that when you multiply that pair, it should give you 12. You have 1 and 12 here itself. Then 6 and 2, when you multiply these, they give you 12. And you have a 3 and 4, when you multiply them, they give you 12. Those are the factors. So when they say break down 12, you write 3 and what? 4 in brackets. Meaning that when you multiply 3 and 4, you get a 12. It's also the same when you multiply 2 and what? And 6, you get a 12. Same thing, same thing. Forgive my writing, sorry. Yeah, I'll be writing better as time goes on. So that is the thing. And what do we have here? When you are asked to factorize algebraic expressions, they are simply telling you that this expression is like a 12, and you have to break it down to its factors. How do you break it down? Let's see in the solutions. 2x plus 6xy. How do you break it down? Remove the terms which are common here from both sides. You factor them out, you put them out of the brackets, So it is 2x. And when you remove 2x here, what do you remain with? In the first term, you remain with a 1 because everything has gone. And here, what do you remain with? You remain with a 3y because x has gone. And how many times does 2 go into 6? It goes in like 3 times. Here is the same thing, 4y squared minus 16. Then here you remove a 4, you factor out a 4. So you remain with y squared minus 4. So what do you have is equal to 4 open bracket y squared minus 4 can also be written as 2 squared. Okay, so is equal to 4 open bracket. This is a difference of 2 squares, so you are going to have y plus 2 and y minus 2. I used to solve these type of questions frequently when I was doing JETs in grade 9, and especially on quizzes and in Olympiads. Factorize x squared minus 5x plus 6. This is a quadratic expression, friends. So here, how do we factorize this one? There is what we call product sum and factor thing. So here you got a product, and here you got a sum. And when you look at this expression, in short, they're asking you to look for two numbers such that when you multiply those numbers, you get a 6 here, a plus 6. And when you add the two numbers, you should get a minus 5, this negative 5. So what are those numbers? You will discover that those numbers are, when you multiply those numbers, you should get a 6. And when you add, you should get a negative 5. What are those numbers? You discover that those two numbers are negative 2 and negative 3. Okay, so here we have x, we write them like x squared minus 2x, okay, 2x minus 3x plus 6. So is equal to, you factor out the common, so you divide this into two parts here. So you factor out the common expressions from both sides. What is common here? You have x, just a single x is common. And what do you remain with here? You remain with another x minus 2. So you have minus, what is common here? A 3 is common. And what do you remain with? X minus 2. And you close. So what is common here again? You have x minus 2 and x minus 3. Okay, so this is our answer. You have factored out the quadratic expression. Okay, so we're going to look at another example before we go to the next section. So So here we've got 3a plus 9b. This is straightforward. What is common here on both sides? 3a. Then you will remain with okay, this is 3. You will remain with 3b. So which is what is common both sides? It's a 3a open bracket 1 plus 3b. Okay, so this is our answer. So next page, algebraic fractions. Just like we have ordinary fractions, we also have algebraic fractions which deal with letters. They deal with both letters and numbers, in fact. So simplify the following algebraic expressions. Simplify the following expressions. Try to pause the video and solve these ones on your own. Let's see what you're going to get. Okay. These are the solutions. In fact, this is a continues up to here as the final answer. So so 1 over f plus 3 over plus 2 over 3f, excuse me. How do you do it? Just the same way like you do with things like 1 over 4 plus what, okay, 3 over 6, and you look for a common factor here, which is 24. In the same way, you will do 4 into 24 goes in 6 times, and 6 by 1, you get a 6 here, plus 6 into 24 goes in 4 times, and you multiply 4 by 3 on top, you have a 12. And as usual, 6 plus 12, 18 over 24. So 18, while okay, here you've got 3 over 4, and that's your answer. In the same way with letters, same procedures are followed when you are handling fractions involving letters. So you'll find that here 1 over f plus 2 over 3f, the same thing, common factor 3f, and you will get 5 over 3f at the end of the day. Then here, the same procedures, common denominator first, and everything follows as you will be handling the letters one by one, and finally you obtain this at the end of the day. So next you have this one. Okay, it's quite complex, such that you've got letters at the bottom. So how do you do with this, which is got letters at the bottom? Same procedures. Example, if you've got 1 over 3 plus 2 over 4. So What is the common denominator here? It's 12. This time around, except that you don't write 12, you write 3 in brackets and 4 in brackets. But it's the same thing. When you multiply 4 with 12 with 3, you get a 12. Here in the same thing, you don't write the direct product of x minus y, x plus y. You write them in form of x minus y and x plus y as a common denominator, like that, so that you don't confuse yourself. So how many times does x minus y goes into everything at the bottom here? It goes in x plus y times. So x plus y multiplied by 4 here on top, you get 4 open bracket x plus y. How many times does x plus y here go into this at the bottom? It goes in x minus y times. And how many times does x minus y, okay, x minus y multiplied by 5, you have this. Then you simplify everything in the numerator here and bring down everything at the bottom. If everything at the bottom can be expanded, you leave them in the expanded form. So finally, when you finish simplifying the numerator, you end up with this here. And you can also go further by putting the denominator in the expanded form like this. Okay, let's go to the part for changing the subject to the formula. Many of the times these type of questions, they don't miss in most of your exams as grade 9s and junior secondary students. You come across these type of questions almost everywhere. So now I'm going to tackle this in a much simpler explanation. Okay, how do you handle such questions? Here I have given an illustration of an equation with numbers and an equation with letters. So what do we have here? You have 3x plus y is equal to 10. And here on the other side, I will draw a line. Here on the other side, you have ax plus b is equal to c. So the way you solve this equation with numbers is also the way you are supposed to solve this equation with letters if you want to find the value of x. Okay, so 3x is equal to 10 minus 1. Let's take a look. Here, 3 here on the part of letters, 3 is represented by A, and 1 is represented by B, and 10 is represented by C here. So 3, here you have 3x, and here you have ax, then 10 minus 1, okay, here the 10 is C and 1 is B. So you've shifted the 1 to the other side of the equation, and here when you shift the B to the other side of the equation, it will become a minus b. So it will be c minus b. So 3x is equal to 9. Here you have ax is equal to c minus b, because you can't subtract different letters, okay, letters of, different type of letters. You can't subtract them, so you will remain with c minus b, just like that. So here x is equal to 3. How did we get here? It's just as good as doing 3x divided by 3 is equal to 9 divided by 3. Okay, so you cancel out everything on the x part, and you have, how many times does 3 go into 9? It goes in 3 times. This is how you arrive at a 3 here. And in the same way, how many times does, in the same way, when dealing with letters, you divide by A, and here you divide by A again, assuming A is 3. So A's are going to cancel here, and here there is no common A, okay? So here you're going to have C minus B over A, because these are letters, you can't cancel them, you can't subtract or add them, as because they are all different type of letters, and you can't there is no A on top, common A on top, and hence you can't cancel out the A's. So I've shown you. Now let's do some few examples on this. Express the following in terms of x. In terms of x, in short, when you see something like this, in short, they're telling you make x the subject to the formula in the following expressions. Y is equal to mx plus c. This is an equation of a straight line, how it is given. Then A is equal to pi x squared. You're talking about the area of a circle. Then S is equal to AB plus x, open bracket, c minus a. So the volume of, then D, the volume of S is the volume of a cylinder. Okay, this must be A. Okay, here the volume of a cylinder, this must be A, is given by the formula V is equal to pi r squared h. Make r the subject of the formula. Okay, try to pause the video and see if you can do these questions on your own. Then we'll see what you get. Okay, assuming that you've done the questions one by one. Let's see. Y is equal to mx plus c. Here, mx, you are making x the subject of the formula, is equal to c minus y. Okay. Okay. Listen. Okay, y is equal to mx plus c. Then here you've got mx is equal to y minus c. Okay, then divide by m, divide by m. Then what do you have? Y minus c over m. Okay, this must be our answer. So y minus c over m. Then let's look at the area of the circle. Make x the subject of the formula. Here, a is pi x squared is equal to a, and x squared is equal to a over pi. And here, what do you do with, since there are two x's here, you square root both sides of the equation. And you get x is equal to the square root of a over pi. That's the answer. Okay, next time we're going to do some couple of problems, some couple of exercises, and evaluate and try to assess ourselves how far we are going to go. Yeah, we're going to do a couple of exercises from various exam papers, from various past papers that we've been writing over the years, so that we see how best we are prepared with algebra. Yeah, then next after that we're going to do a couple of topics so that we can catch up with time. I don't know, like before you guys get to write your examinations. Examinations can be anytime, can happen at any time. So just be prepared, just be ready, don't be relaxed. Continue studying. All right, all the best. Um, don't forget to like, subscribe, and share so that many people can get to know about these lessons and you get to be enjoying. Don't be selfish. Let's share to our friends. Yes.